Hey everyone. So today we're going to dive into one of the most fundamental tools for thinking clearly. Now, I know it might sound like something straight out of a math textbook, but trust me, this is a skill you use every single day. Whether you're solving a puzzle, making a business decision, or, just trying to guess what happens next in your favorite show.
Okay, so let's just jump right in with a quick mental warm-up. You don't need a pencil or anything, just your brain.
So take a look at this sequence of numbers here. We've got 4, 8, 12, 16, 20. What feels like it should come next? I'll give you a second. Yeah, I'm pretty sure you've already got it.
And there it is, 24. Of course. The pattern's pretty simple, right? Each number is just 4 more than the one before it. Your brain spotted that pattern and made a prediction. And that little intuitive leap, that is exactly what we're talking about today.
So, that thing you just did, that little mental jump, well, it actually has a formal name. You are participating in the art of the educated guess. And this is how scientists form hypotheses, it's how companies predict market trends. Really, it's a cornerstone of how we make sense of the world around us.
Let's look at another one. Here we've got a list of appointment times. 8:30, then 9:15, 10 o'clock, 10:45. You can see the pattern, right? It's just adding 45 minutes each time. So the next logical appointment would be at 11:30. We do this kind of thing instinctively, all the time, without even thinking about it.
This whole mental process, seeing a pattern and guessing what comes next, well, it has a name. It's called inductive reasoning. You can think of it as the engine of discovery. It's what lets us go from a few specific examples to a big general conclusion. And that educated guess that you make, that is called a conjecture. It's not just a random stab in the dark, okay? It's a theory, a conclusion you're forming based on the evidence you've seen so far.
I absolutely love this analogy. You're the detective, the numbers or the shapes or whatever are your clues, and the conjecture, that's your theory of the case. It's your best explanation for what's going on.
Okay, so here's where this gets really, really powerful. Let's just run through a couple of quick examples to see how we can build what feel like solid, totally unbreakable rules just by making these educated guesses.
All right, let's see. What happens when we multiply two odd numbers? Okay, 3 times 5 is 15. That's odd. 7 times 11 is 77. Also odd. 1 times 9 is 9. Still odd. I think we're seeing a pattern emerge here.
So, based on that evidence, we can form a conjecture. The product of any two odd numbers will always be an odd number. It feels right, it's held up in all our tests, let's call it a rule for now.
And what's really cool is this isn't just for numbers, it works for shapes too. Take a look at these figures here. These are called isosceles trapezoids. And those lines we've drawn on the inside, those are the diagonals, connecting the opposite corners.
Now, if you were to actually measure them, you'd find that the diagonals in each one of these shapes are the exact same length. So, we can make another conjecture. The diagonals of an isosceles trapezoid are always congruent or equal. It's pretty powerful, right? We're spotting what seem to be universal rules just by looking at a few examples.
It almost feels like we have a superpower, We can look at a few things and somehow uncover these deep truths about how the universe works. But there's a catch. And believe me, it is a big one.
Just because a pattern holds for 3 examples, or 10, or even a million examples, does that absolutely guarantee that it's going to hold true for all of them?
Let's test a new conjecture. So a prime number is just a number that's only divisible by 1 and itself, right? Our conjecture is if you take any prime number and add 1 to it, the result will not be prime. And hey, it seems to work. 3 is prime, 3 plus 1 is 4, not prime. 5 is prime, 5 plus 1 is 6, not prime. 11 is prime, 11 plus 1 is 12, not prime. I mean, this feels like a solid rule.
Until you consider this number, the smallest prime number of them all.
Let's try our rule with the number 2. Well, 2 is a prime number, but 2 plus 1 is 3, which is also a prime number. And with that single solitary case, our entire beautiful conjecture just crumbles into dust. It's false.
And that one devastating case that blows everything up? Well, it has a name. It's a counterexample. You can think of it as the ultimate weapon against a faulty idea. It doesn't matter if your rule works a billion times. If you find just one counterexample, the rule is broken.
period. We can see the same exact idea in geometry. A common assumption is that if two angles are equal, they have to be vertical angles. You know, the kind you get when two lines cross and make an X. But look at this picture. Angles ABC and DBE are the exact same size, but they are clearly not formed by crossing lines. So this one picture is a counterexample, and that conjecture is proven false.
So does this mean making conjectures is just a waste of time? Absolutely not. In fact, finding out you're wrong is actually one of the most important parts of the whole process.
This right here is the key takeaway. A counterexample isn't a sign that you failed. It's a sign that you succeeded in finding a deeper truth. It stops you from building your ideas on a shaky foundation. It forces you to refine your thinking and pushes you toward a better, more accurate understanding of things.
So let's just boil it all down. A conjecture is your bold theory about how the world works based on the patterns you see. The counterexample, that's the unforgiving stress test that separates the theories that are truly solid from the ones that just look good on the surface. They're two sides of the same coin, and they work together to get you closer to what's actually real. And that leaves us with a final question to think about. We all operate on conjectures about people, about our work, about the world. So what's the common belief or assumption that you hold that might just fall apart if you found the right counterexample? Think about it. Thanks for tuning in.